Okay, so we are going to be doing some more differential equations, except we're going to solve them in this section. So just like last time before we went on break, we are going to be solving differential equations. And just as a reminder, when we are looking at this format, what this is saying is that the derivative of some function is equal to this. And what we're going to do is we're going to try to figure out what function that is. Now, there's a lot of functions that if I take the derivative of it, we can get that function, which is why we have all those plus c's at the end. So what this question is particularly important for us is, what if we had the point 2, comma 1, because that's what that means here. 1, comma 2, because if we say f of 1, so that means x is 1, so 1, comma 2. So what if we had exactly the point 1, comma 2? Then what would that mean in terms of our function? What c value would we have? So we're going to solve this like we normally would. Let's start off with a. I'm going to write down the equation so I can... Okay, so we are going to split up the dy and the dx by multiplying this side by dx, and then we're going to divide by y minus 3. So we end up getting... Next, we're going to go ahead and take the integral of both sides, because I have a dy and I have a y, and I have an x and a dx, so let's write this. Okay, now we're going to say, well, what is the integral, or what is the antiderivative of 1 over y minus 3? Well, so what is the antiderivative of 1 over x? And that's just going to be ln x. So what is the antiderivative of 1 over y minus 3? Well, that's going to be ln y minus 3. Now here's a problem here. I'm gonna write that plus c, and I'm going to change that in just a second. What's the antiderivative of 3x squared? That becomes x cubed. If we take the derivative of that, the 3 becomes down, so that's just no coefficient there. So the issue with this is we actually have to make this positive. We have to put absolute value. Well, why does that make sense? Well, if I take the ln of anything, and you can just try, what happens if I take the ln of a negative number? Like, what's the ln of negative 3? It doesn't make sense, because the log with a base of e to what power makes a negative number. So e to no number makes a negative number, so you can't have a negative number, which means that this needs to be positive. So we're going to say that's the absolute value. Now I'm going to write this as an exponent, and this is a log base e, so e to this power equals this, and then I'm going to get rid of the c there, because that doesn't matter when we're next to our y. So we're going to say this is e to the x cubed plus c equals absolute value of y minus 3. Now, just like our other differential equation problems, we're going to solve for y. In order to get rid of the absolute value, we're going to get a plus or minus. So this is going to be plus or minus e to the x cubed plus c equals y minus 3. And then I'm going to add 3 to both sides. So we have 3 plus or minus e x cubed plus c equals y. So now we have a possibility of 2 answers. We're going to actually deal with this plus or minus in just a second. But now we're going to plug in our information. We know that our x is 1 and our y is 2. So we'll plug that in there, because we're now going to solve for c. So we have 3 plus or minus e to the, what did I say, x is 1 equals 2. And so let's go ahead and subtract the 3 onto the other side. This is just 1. Negative 1. So what happens here if I take the ln of both sides? So if I say ln of this guy and ln of this guy, well, I can't have the ln of negative 1, which means that one of these answers doesn't make sense. So the plus answer doesn't make sense, because I need to take this negative and I need to make it positive, which means that I'm going to write the ln of e to the 1 plus c, ln of 1. Like, this is me taking out the negative sign and dividing them both sides, so we get rid of the negative. The positive one is going to be a non-real answer, so that's we're not going to consider that case. So the ln of e to the 1 plus c is just going to be 1 plus c. And then the ln of 1 is 0, because e to the 0 power equals 1. So c equals negative 1. So if c equals negative 1, we can plug that into our original problem we had up here. So we have y equals 3 minus e to the x cubed minus 1. And that is going to be our one original problem that if we take the derivative, we will end up getting this. Let's go ahead and do that for our second problem. I think we have time for that. How much time did that take me? I'm wasting time by checking the time. Yeah, okay, cool. So let's go ahead and do B as well. So we're going to do the same thing. I'm going to write down the problem. We are going to move the x, the dx, onto the right side and the y onto the denominator. And we're going to take the integral. So what is the antiderivative of 1 over y squared? Before you jump to thinking that it's just like this problem, this is really saying y to the negative squared. And y to the negative squared, the antiderivative of that, is since when you take the derivative of a negative exponent, you subtract 1, we're going to get y to the negative first. So y to the negative first, but there's a 1 coefficient here, which means that I need to put a negative sign here. So this is going to be y to the negative first plus c. And the antiderivative of x is going to be x squared. But when I take the derivative of x squared, we need to multiply it by half so that it gets a coefficient of 1. Let's say plus c there. Okay, so I'm going to rewrite this as negative 1 over y. I can get rid of the c on this side. Once again, the way we can get rid of the c on one side is because I could subtract c and I could subtract c. They don't cancel each other out because there's still going to be a c somewhere. So we only need one of the c's. And I need to solve for y. So actually I could do this. I could do this now or I could do this later. In the example that I tried out earlier, I did it later. So I'm just going to do it later. We're going to plug in the points 1, 2, I think, right? 1, 2. So we have negative 1/2, 2. All right, and we're going to solve for c. So, whoops, put a 1 there. So this is going to be negative 1/2. And then we get what? Negative 1. All right, so now we're going to plug this back into our original function up here. And now we need to solve for y. So I'm going to multiply my y into their side. I'm going to divide it by this, so negative 1 over. And then I don't like having a fraction over a fraction here, so I'm going to multiply everything by 2 over 2. So 2 times negative 1 is negative 2. And then 2 times 1/2 is 1, so we get x squared. And then 2 times negative 1 is negative 2. And so there we go. What I would like you to do before I go do my third one here is I want you to try C yourself. So go ahead and pause the video. Go ahead and try C. Okay, so I hope that you got an opportunity to try C. I don't want to burn up too much time, but you can ask me how to do C tomorrow. But there you go. All right, and your assignment is just going to be one problem, and it's going to be just A through D. So nice and easy. Have a good one. I will see you guys later.